Okay, so first of all, hi, my name's Mike Bursell. I am the Chief Security Architect for Red Hat. I work in the CTO office, doing the coolest, funnest, sexiest job because it's security. And as everybody knows, security is just cool and fun and sexy. So I'm going to try and convince you of that, maybe, in the next half an hour or so, by talking about security in one particular context, and that's DevOps. So as you may have seen, the title is DevOps or Security, moving to and. These should not be separate things. We need to think about how they work together. So this is just a brief run through what I'm planning to talk about. First, what is DevOps? Who here kind of has a good feel by now of what DevOps kind of means? Okay, a smattering. I'm going to have to explain. I'll explain that, and then I'll talk about what I mean by DevSecOps as well. Sometimes you hear SecDevOps or whatever mashup of those, but we'll stick with DevSecOps for this discussion. Then I'm going to talk about some of the steps that you might be going through in DevOps and where security might fit in that, and then talk about why containers are a very good fit here. And then move on to some very specific things you need to be thinking about, or you could be thinking about as you go through your DevOps deployment with containers, and hopefully by this stage with security as well. So I've tried to find a nice, concise definition of what DevOps was and failed miserably. So I'm sorry about that. DevOps is the practice of operations and development engineers participating together in the entire life. If you can't say it in one breath, it's not a great description, right? But it kind of captures it. It's about not allowing the dev folks and the ops folks to be separate, and understanding that it's all about the entire life cycle. So if we accept that, and I've got a nice sort of loopy diagram which makes life even more complicated to understand, what's DevSecOps? So the purpose and intent of DevSecOps is to build on the mindset that everyone is responsible for security. You'll notice it doesn't actually say what DevSecOps is, right? But at least it tells you what it's trying to do, which is, I guess, a start. Everyone is responsible for security. And I'm well aware, it was quite clear from your faces at the beginning, that not everyone believes that security is cool and exciting and sexy, and therefore you don't think you should be involved with it, or at least it shouldn't be the top thing. It is, and you should be. So let me convince you of that. So I was in a meeting a few weeks ago, just before I was putting these slides together, and a colleague of mine says, oh no, for 20 years, people have been leaving security till last. He's a security guy as well. He's jaded like the rest of us. And I said, you could just have missed those last two words out. People have been leaving security because they don't think it's cool. So the problem is, this is what it looks like. We have all done the classic waterfall project, right? We know we have. We pretend we haven't. We don't use it anymore, but it's there. It's embedded in our processes and all that sort of stuff. We have the design, develop, test, stage, deploy, classic. And then someone points out that it might be a good idea to do a bit of security at some point in the process. Okay. So the project manager says, I know what, I'll put it there. It'll be nice and quick, just before we deploy it, we can get it sorted, and then we can go to deployment, and it'll be fine. And this is what the project manager expects it'll take. He hopes, anyway. Unluckily, of course, the security architect has been around for a bit longer and kind of knows that it's going to be at least as long as all of the others. And then we actually get to how it really works, and it looks like that, right? And that's because you just can't do it at the last minute. If you try and do security at the last minute, you're going to run into all sorts of problems. We've all been there. We've all done that. So at what point do you insert security into this process? There is no obvious point, partly because it's this sort of Oribus, is it? The sort of self-eating snake thing. It's a dangerous thing to say about DevOps, but there's no obvious place. So what I'm going to do is I'm going to give you a slightly simpler picture to use around DevOps. I'm going to use it partly because I can put security in one place, which is in the middle, rather than separating it into two bits. So like I said, just a nicer, easier picture, and I don't have to talk quite so long about it, because I can say it's in the middle. And a really nice quote from one of the security demigods of the world today, arguably Bruce Schneier. So Bruce Schneier has been around for quite a long time. About 20 years ago now, he wrote one of the seminal works on cryptography called Applied Cryptography, where he explained that with cryptography, the world would be a perfect place. It would be brilliant, everything would be simple. And then about 15, 20 years later, he wrote another book called Practical Cryptography, where he admitted that he was completely wrong. And actually, that people were kind of important when you're doing security as well. And here's how to think about it. He's since gone on to talk about security more generally, and is a very interesting guy to read. Secrets and Lies is one of his great books. I heartily recommend it, and a lot more. Has anyone here even flicked through Applied Cryptography? The big thick? Yeah, okay. You know what I mean, right? Yeah, that's readable. It's got words in it. I kid you not, really. So let's just briefly go through some of these bits, some of these steps in the process. So again, this is a gross oversimplification, but just so we know what we're talking about. So the design phase is where you work out what your security requirements are and what your governance models are. This is where you start thinking about things like risk and compliance, because security, there's no point in doing security on its own apart from the fun of it. It's got to fit into an actual deployment, fit into a regulatory environment, set into compliance environment. It's got to be about risk, right? What we're doing as IT folks all the time is putting risky systems out there. Now, the amount of risk is something that we have to work with the business to understand. We shouldn't just say, well, this is acceptable, we'll do that. It actually should be a conversation with the business about risk. Because the only truly secure system, really secure, I can build you a secure system. What I'll do first, I'll take all of the networking plugs out, including the wireless stuff, right? I will take the power out. I will take the hard disk and any SSDs out as well. I will drill through them in several places, encase them in concrete, and shove them down the bottom of a very large well. Because that's the only way you're going to get perfect security. So you need to understand what you're doing and why, so you're making sensible choices. And that's got to be part of the design phase. Are you in a HIPAA world? Are you in a SOX world? Are you in a telco regulatory world? Whatever it may be. So we then think about what we're building. And again, clearly, if you just bolt on at the end, it ain't going to work. Okay? You have to design security into the system, or it's going to fail in all types of very interesting, exciting ways. And if you want to be up at 2 in the morning on a Saturday or a Sunday fixing stuff, then great. But I really suggest putting stuff in the beginning rather than bolting it in at the end. And once you've actually built something, again, if you want to, you probably want to run it too. But you need to understand that deploying something, it doesn't run in a vacuum. It's got to run on something. And that something had better be a trusted platform. A platform which you know how it's going to behave, that is hardened against the sort of threats that you need to worry about, will support the sort of regulatory and governance models, as well as your application being able to do that as well. And then, of course, you've got to run stuff. Automation, automation, automation. Again, think about compliance. There's no point in doing this unless you're doing it within a context, a security and risk and compliance context. And the last step. I try very hard not to say customers are the enemy. Mainly because it gets me in trouble with my sales guys. And I understand they've got a job to do, and customers are lovely people. You're all customers, right? So we love you, right? But your customers, maybe they're the enemy, right? There's a great military strategy adage, I think, from Otto von Bismarck. I'm going to be wrong now, tell me afterwards. Which is a plan, however good, never, never goes past, what's the word, never survives first contact with the enemy, that's right. So as soon as people start using stuff, it's going to go wrong, because they're going to use it in ways you don't expect. And then you'll be in trouble with the real enemy, which is higher management. So, let's just take this as the basis for how we think about stuff. And the steps in purple on the right, for those of you who have color-blind issues or can't see it very well, the steps on the right with boxes round. These are the ones which are most obviously dev and ops, right? They're the building and running and managing it. But my strong contention is that if you're not doing the other two as well, you're not really doing DevOps. Because it is about the life cycle and about everyone being involved throughout the whole process. It's not just your developers being operators or your operators working with the developers. It's also about your security folks being involved, about architects being involved, about the business discussions you have with the people in your organization and with your customers about what you're actually going to do. Otherwise, you're just throwing stuff out there. So, let's talk a little bit about containers and go through a bit about why they may be useful in DevOps world. So, who here has a pretty good view on containers? Okay, smattering. That's fine. A little secret for you, okay? And this, if you didn't notice the number of hands that went up, it wasn't very large. A large percentage of the customers we go into feel that they are behind everybody else in terms of their adoption of containers. Okay? So it's not just you. So let's delve a bit into containers, and then we can talk about why they fit so well into the DevOps model. So this is a slide that I have stolen from my boss, because it makes him think that I'm paying some attention. But actually, I quite like it. What it talks about is the difference between your legacy way of doing things and, classic VM. Isn't it weird that VMs are now legacy way of doing things, and the new DevOps container world, right? And now, don't get me wrong, VMs are here to stay. They are not being completely kicked out by containers. Bare bones is probably here to stay as well. It's just about what you use and when, and that's part of your architecture and your security story. But we're talking about DevOps, so let's talk about some of the benefits that the DevOps way of doing things can give us. So the first thing is, you're moving from a monolithic, big old, one single application, one thread of control, all of that sort of stuff, through the end tier and into microservices. Microservices are basically broken down bits of your application that can be consumed by lots of other bits of the application. They are little small services, daemons, processes, all those things, which can be used by lots of different bits. It's one of those magic words at the moment which doesn't need to be magic, frankly. Your big old data center, you move to hosted, and then you move to hybrid, and possibly these days, multi-cloud deployments, where you're not just saying, I'll deploy all of my stuff to Amazon, or all of my stuff to Google. You say, well, actually, I'm going to keep some of my stuff on-prem, some of it in Amazon, and for failover, maybe, some of it to Google, or Azure. As you've heard today, we talk about Microsoft now these days. It's kind of a bit of a culture shock, but they're really good partners of ours. So you're thinking about what you deploy where. And we move from this horrible waterfall model that I talked about before through agile and then hopefully into a DevOps world. So let's look at some of the differences between these things. As before, I've possibly slightly unfairly labeled VMs as legacy, but I think although VMs certainly moved us on in terms of our architectures, they really don't embrace some of the cool new stuff that we're going to be wanting to talk about for DevOps. So let's just go through this quickly. Size. In terms of size, DevOps is about the small. Containers are about the small. Whereas for a VM, you might be packaging your existing application basically in the same way that you would before, but just shoving it in a VM so you can move it around if you need to. Or maybe cutting it up into 3 or 4 pieces. In a containers world, you're going to be splitting it up. That's what the composition thing is here as well, into lots of small, lightweight pieces. And you can deploy those, you can spin them up, you can spin them down as you need to. Why do you need to think, okay, I have this big, horrible application, I need to deploy all in one go, and I can never change the different bits in it. What if I have a bit that I need to change? Let's say I need to change the presentation layer. I want to add a new widget to the presentation layer. What about if I want to change the searching capabilities? I want to add a new way of searching the database. What if I want to add a new storage type? Why should I need to deploy the whole thing all in one go? You shouldn't need to do that. Okay? And that is what DevOps is about. That is what decomposition is about. You get these small, lightweight things that you can spin up, spin down, and we'll come to in a minute, you can change them as you need to, and it doesn't take too long. So one of the design patterns around DevOps and containers is that generally you want stateless pieces, so that if you lose one of these pieces, it goes away, and you haven't just destroyed your entire application. You're going to need to keep state somewhere. And there are times that you want to use a different design pattern, but generally, stateless means it comes up, goes down, done. Every time that you make a Google query, a new container is spun up, services your query, and dies. They are that ephemeral, or can be. They don't need to be, but that's the sort of time you're thinking about. I was with a customer a month or so ago who says that he, as the architect, is trying to enforce a no more than 24 hours life cycle for any container piece. No more than 24 hours. And by that, he means it comes up, and if it's still alive 24 hours later, it's going to be killed. Now, that's a different way of thinking about stuff, right? So, the other thing about containers is that they are generally more loosely coupled with the infrastructure. Now, VMs have gone some way to decoupling you from that infrastructure, But often, they're going to need specific capabilities. And we had one of the customers who was speaking up earlier on the panel talking about how we're getting closer to commodity hardware. So that will get better. But containers just expect it. They don't really care where they're running. And the development cycle, again, I've talked about this. Obviously, building your initial application, that's going to take a while. Let's not pretend it doesn't, although you can probably spin something up as a proof of concept fairly quickly. But once you've done that, again, because you've got all these different little pieces, as long as you've got well-defined APIs and ABIs between them, you can just swap them in and out. You just create a new one, right? That's the sort of doing it every day, creating a new one every day. Again, one of the other partners was saying, I think it was Massimo, was saying, they can roll out several, each team can do 1 or 2 of these a day, a new version. A hugely different way of thinking of the world to, your VM, which you work on for 6 months, and then you put for staging for 3 months, and then UAT, and then actually rolls out. It's a completely different way of thinking about it. So the other thing I'd just quite like to do briefly is to discuss, we said, what is a container? I didn't really tell you what a container is. People like to say there is no mention of containers in the Linux kernel. And that it's kind of just and these are kernel folks, right? It's just a conception, an encapsulation of ideas and abstraction. If you do a quick grep on the latest kernel, and I know because I did it, yeah, I know, there's about 14,000 references to containers, so it's not quite true. But they don't exist in quite the same way that VMs do, right? So people think of containers and VMs as the same sort of thing, and they are absolutely and absolutely not the same thing, which I always think is really helpful, right? So they are, in one way, yeah, the same sort of thing. They are a thing that you can run, a thing that you can execute, which runs on top of another host, and you can run lots of them on the same host. That's like a VM, right? It's like a VM. The way they do that's a bit different. They don't use hardware virtualization to do that, the way that VMs do. They use namespaces, and the kernel, the Linux kernel in this case, separates containers from each other. So as far as they're concerned, they're running on their own. They can't see other containers, users or processes or I/O, any of that stuff. It's kept separate, and they're kept separate from the kernel as well. So it's kind of a bit like a VM in that way. But the other thing that containers are, which VMs really aren't, is a packaging format. When you deploy a container, what you're doing is taking an image which is defined in a particular way and doesn't need all of the stuff that a VM needs, a full operating system and all those sorts of things. It could be really cut down. And you can have different types of container image. It might be one that you use for your database queries, one which is an Nginx one, for instance, or a presentation layer. And you take those and you put just what you need in that to do the things that you want to do for that particular type of container. And then you run it. So that's very different to a VM. So I've probably muddied the waters horribly there, but we'll just carry on anyway. The things to remember are that they are small, they run light, they run stateless, and they are loosely coupled. So I haven't mentioned security for about 10 minutes, and obviously I'm getting a bit of withdrawal. So I'm going to ask, which of these are security issues? And you all know the answer, right? You know what I'm going to say, don't you? They're all secure, because I'm a security guy. I've got a hammer. Everything looks like a nail. Everything's a secure, but these really are all security issues. If you go into each bit of them, there is security stuff you need to worry about. So let's talk about what options we have and what we can do, if I can get this to move on. Was that the right one? Yeah. How containers can help us with some of the steps in our DevOps model. Now, some of these are steps. We've got, the contents, the building, the deploying, all those sorts of things. And some of them are pieces that we need to be doing, part of the infrastructure, part of the landscape of our deployment. And I'm just briefly going to talk about some of the things you can think about, some things you must think about if you're going to think about security in a DevOps world. So let's start with provenance. Where do your containers come from? So as I said just a couple of minutes ago, you're going to get your containers from a place, right? Now, there are multiple places you can get your sort of unbranded container that you haven't put stuff in yet. Amazon provides them. Docker provides them. Red Hat provides them. But we all know that developers like their shinies. They like the new cool thing. They'll do a search on Google. And they say, oh, there's this thing. I'll use that one. It's the top of the list on Google. They don't even go down to the second line, let alone the second page. I'll use that one. And they'll just download it and try and use it. Now, that's not a good thing, right? There's no good there. You need to know that you're only using those base images, those base container images, that have come from a reputable source. And that source is updated regularly, because if you're using a container image, the base image, which you downloaded from a trusted repository 6 months ago, how many CVEs are going to be against that? How many patches? How many updates? You just know they're going to be there. So you need to make sure that you're using a registry which is updated regularly. And that is updated by people who should be updating it as well. It's not just say, okay, we've updated it regularly, but unluckily my friends from Smolensk have access to that particular registry. If you have developers who you trust in Smolensk, that's great. I do apologize. It could be Newbury in the UK. I don't know. People you don't necessarily trust, right? The Brits probably just as bad as the Russians, I guess. Oh no, Commonwealth. You have the Queen's head on the currency. It's real money. So you need to worry about that. So let's talk about the content. So once we think about that, you need to worry about what's in your container. Even if you've got that updated container base image, again, we have the shiny problem. It's not just the container, it's what you put in the container. So we've got the shiny issue. I need to use a new library to do this stuff, because I definitely need 14,000 digit floating point for my bank arithmetics. So, I'll just do a search. There is a new one. I'll download that. So the libraries that go inside your container, they could be doing bad things. Or it may have started off okay, but it might have been compromised. So you need to be able to be sure that actually you can manage these. And of course, then there are app layer problems, which may not be initially visible from your single container view, and all the stuff running on that platform as well, which we'll come to in a minute. And then there's building. Now this is where DevOps and DevSecOps really comes into its own. So I said before that you need to think about not just your dev people and your ops people, but also your architects and your designers and all those sorts of people as well. When it comes down to it, different sets of people, different roles, should have different capabilities. Oh, it's almost like RBAC, isn't it? So if you say, to take an example, my operations people can define which base images we use, which base container images. They can say, from this registry, this team can use this one, this one, this one, and this one, but not this one. Okay? So you've got a starting point. And then you say, okay, well, the architects who are going to be, providing the bigger level picture will say, okay, we're going to use Enfuse and AMQ and JBoss data visualization of these particular versions. They don't get to change the base image, but they get to say some of the stuff that goes in it. And then you have the application developers who are actually building stuff using those things. And if you build things right, and if you make sure that your CI, CT, CD, continuous integration, test, and deployment models are properly instantiated with the policies that, remember we talked about compliance and stuff earlier on, which meet those policies, you can tell if, for instance, an application developer has chosen a different image. Because as you take it through the testing and deployment process, you've got automated controls which say, that is not an allowed image. Now, if it had been replaced by one of the operators, one of the operations folks, then it would have been okay, because they have permissions to do that. That's part of their role. But you can see who's done what and put automated policies to say, no. Normally, if everything was through, I would deploy this straight out. Straight out, maybe to 2% of my users if it works fine, maybe 5, 10, 15, and then to my entire user community. Again, one of the great things you can do with DevOps is kind of canarying. But you can stop it right at the time when people do the wrong thing. When those shinies come out, you can say, no shinies. Not without permission from the grown-ups. I used to be a developer. They also look like grown-ups to me, grumpy. And once I get that flag as a developer, and I realize, okay, I did the wrong thing, and I change it, I shouldn't need, to then push all the buttons to make things go through every step. Your DevOps platform should say, I notice there's been a commit of that new code. Let's run it through. Let's make it all happen. And as long as nothing is noted that shouldn't be happening, you go straight through. That's the promise of DevOps, with DevSecOps built in. So I tend not to talk about products. Again, sales guys hate that. But there's one I'm going to mention here, which is Atomic Scan. Atomic Scan is an API which allows you to check as you go through your DevSecOps or DevOps CI/CD process, and it will automatically scan your container images to say, yes, this meets, for instance, a particular open SCAP standard, or doesn't. So Atomic Scan, you can write your own scans as well. It's open. This is Red Hat. It's an open product. Heartily recommended. Does great stuff in this sort of situation. So let's carry on. Deployment. Well, I've already talked about some of this already, about deciding what can be deployed, what can't. But also, there's other things you can do. It's just, if the developer, it's not just downloading the wrong things. They may have done practices which are not allowed according to your policies. Giving containers root. Classic, don't do it. You can stop that. And of course, if you realize, so this is another one of the fantastic things. Let's say you've got your deployment out and you've got 3,000 containers. and 500 of those are based on a particular image. Okay? Now, a new version of that base image comes out. It's deployed in the registry. That means you have to go and get it and rebuild all your stuff and then put it through. No, you don't need to do that. Why would you do that? You can have automation see that new version of the image is there, bring it in, put the latest versions of whatever your dev folks have done and the architects have done, roll that through with what they've got, and then start deploying it. Again, you probably do your canary, 5% and stuff, but you don't need to be, doing all of this by hand anymore. Why would you? Oh, and message, to let people know things have happened, log it, and audit it. Because again, compliance and risk is about understanding what decisions you've made and being able to look back forensically if needs be to understand what changes need to be made. So let's just talk about the host briefly. I said early on that you need to be running on a platform that you know what it's doing and what it's running. You need to be running on an OS which can keep those noisy neighbors, those bad neighbors, those containers which are misbehaving intentionally or unintentionally from affecting the rest of the behavior of your system, whether that's the other containers on that host or the host itself. And who knows about SE Linux? Put your hand up if you know about SE Linux. Keep your hands up. Keep your hands up. Put your hand down if you turn off SE Linux. Okay, and with some honesty now, folks. Okay, that's not bad, actually. So SE Linux, thank you, you can put them down now. SE Linux is a thing built into Red Hat Enterprise Linux and all the stuff we do, which allows you to have very granular control of what processes, and in this particular case, containers can do. And it has a reputation for being very difficult to use, which is not entirely fair these days, but it turns out that it's very easy to use with containers. So leave it on. The main guy who designed it is a guy called Dan Walsh. And every time someone sets SE Linux in force to false, he dies a little bit inside, folks. And fun as that may be, and I have thought about designing a little script which just turns it on and off, on and off, on and off, but don't do it, okay? You should leave it on. So there's a number of other controls, but those are the sort of things you should be doing. And, at Red Hat, we take this seriously. It's absolutely something that comes, and it's turned on by default. What other stuff you can do? Well, when you're running a deployment, an application, right? First of all, you should separate it using virtual networks, or physical networks if you wish, from other applications. There's no reason why your mortgage application your mortgage application, should ever be able to communicate with your PIN changing application, for instance. So if they should never be able to communicate, and that's in the design specs, in the security policies, make it so they can't. Just set them up on, this is not difficult anymore, set them up in different networks, virtual or physical. But also go a step further than that. Because why would your presentation layer, for instance, ever need to talk to your back-end database? It doesn't. So put them in separate networks, or at least put in controls, SDN controls or firewall controls, whatever you will, to stop that happening. So that when they try to do that, it doesn't work, but also you know that it's happened, and you can take some remedial action, because either it was badly designed in the first place, or someone's compromised something, and that is a bad thing. Now, this last bullet is something that I have done. I put my hand up. It was a long time ago, but it still hurts. When you write an application and you're testing it, it connects to your test database, right? Some people can see where this is going. When you move it in production, you of course remember to change the configuration so it's not talking to your test database with all the made up data about customers, but it's talking to the real one. So yes, I forgot to change the configuration, and for a higher number of minutes than I would have liked, customers were seeing the test data that I had made up, and it was not pretty. When you deploy stuff, when you automate this, make it so it never happens. One, deploy to separate network segments, but two, part of the automation process should be checking that those configs have been changed, or in fact, just change them anyway. That should be part of your deployment. Just should be said, it never, ever, ever happens. And you don't get called up, yeah, that whole thing. It's just horrible. So don't put your developers through it. Make it easy. Just do the segmentation. We're nearly done. APIs. API protection and is a very strong set of things you can do. You've got a lot of things you can protect there. You can do authorization, authentication, you can do encryption. You can use things like, again, I don't tend to mention products, but 3Scale is a great product to do this sort of stuff. And you can do rate limiting as well. And this sits alongside all of the network segmentation stuff, gives you those layers of defense and depth that we security people are always going on about and boring you lot with. And last but not least is the platform. This is the container and DevOps platform. If you use a platform which has this stuff built in, you don't need to make it up as you go along and follow all the steps that I've told you about, because it'll come with it baked in already. If you've got RBAC and an integrated registry, you can configure different policies for your CI/CD, and you're running it on hosts. All the networking management, all the storage management, API management. I'm not going to tell you what products to use. That's for the sales folks, my friends. But think about what you're doing. Think about putting this all together and making it easy, because the point about DevOps isn't about making your dev and your ops people's lives more difficult. It's about bringing them all together and helping security be baked in. I don't like saying that we at Red Hat will make you more secure. Particularly if you just say secure, because I don't believe there is secure. But I think you've had enough people coming to you and saying, we'll make you more secure. What I want to do is make it more difficult for you to do stuff insecurely. I want to make it so it just happens and it's baked in to the policies that you've written, with the tools you're using, it's just there. DevOps doesn't just let you do security, it makes you do security. All integrated, because you can't bolt it on later, because there is no single place to bolt it on later. And luckily, containers help. They're actually very well suited to DevOps. Without containers, we probably wouldn't have DevOps in the way we think of it now. And of course, right at the beginning, I said, what is DevSecOps? And I didn't give you a definition, I gave you a description of the sort of things it involves. And I'm going to continue not giving you one. I'm really sorry. Because it really is about changing the mindset, changing about how you think about doing things. Not just the tools, not just the technology, it's not just the processes, it's not even just the people, it's how you think about doing things. And people sometimes ask, how can I make my security people talk to my dev peoples, and my ops people. And part of it is making it part of the same process, right? Making it all put together. Another part is helping everyone realize that the security folks are not the enemy, really. It's not us or customers or even higher management. We're not the enemy. We all want the same thing, and it's not even really that the app will deploy on time so we can have the party and get the t-shirts. What we really want is for us to be able to deploy apps for our companies which allow our companies to continue making money and continue paying us. And we should all be working together for that, right? That's what we should be doing. And someone 2 days ago asked me the same question someone asked me last week, which is, how do I do that? How do I get people to talk to each other? And I have a secret. It's called beer. Or tea, or whatever your tipple is, English tea and then beer. Getting people together in the same room, or pub, or wherever you do these things, and realizing that they are all people and they have the same goals really helps. Change the mindset about what security means and who security people are, and maybe fewer people in security will go home at night and weep in their pillows. And that would be a good thing. Thank you very much.
All right, thanks, Mike. We have time for one question.
It's either the perfect presentation or the worst presentation either. I'm never sure which.
I'm going to say perfect. I'm going to go that direction on that.
Oh, we found one down.
Right there.
Oh, yeah.
So the question I have is something that I was curious about. Is for something like an antivirus protection type solution, does that belong in the continuous itself, or does it belong in the whole tool?
Great question. So the gentleman asked for something like an anti-malware or an intrusion detection system, does that fit in the container or in the infrastructure layer? And the answer is yes. Both. It really has to. And sometimes, if you're in a sort of a deployment where you're deploying on public cloud, you can't see the stuff underneath, and all you can do is the stuff that you can see. But in the best case, you get to see both, or you can control bits of both, and you can get some information in your cloud provider as well. The answer is, yeah, generally both, if you can. But a lot of the stuff has to be behavioral as well, because these are very short-lived things often. Great question. Thank you very much. Catch me afterwards. I will be around, but we do need to get on. Yeah. Thanks very much indeed.